to go ahead and research looking at roots. First, I'd like to just take a moment to look at a few things here. All right, so neither one of these are factors. Why? Yeah, we have a remainder here. But if we had a remainder of 0, they would both be factors, correct? They're both factors of this polynomial right here. They're factors of it. But this one could be factored further, maybe. We don't know. We could investigate that, right? So that's what we're going to start thinking about today. I really like to just ask ourselves, what do we need to know when we're solving a polynomial function? So talk amongst your table groups, maybe one person write down, try and come up, see if you can unveil, what is that, 3, 6, 8? See if you can unveil the 8 things that I think that you need to think about when you're solving for a polynomial. What does it mean to solve for a polynomial? I'm finding all the zeros, right? That's solving a polynomial function, and then I can graph it. Kane, did you have a question? Sorry. Okay, so you guys work on that for about 1 minute. 2, 1. Okay, so I'm going to unveil them. I heard one that I don't have up here, and I was impressed. I'm going to have to add it. Okay, so here's my number 1. Is the function positive or negative? What would that matter? Yeah, see how it's going to be graphed. What's the behavior of it, right? Okay, here's my number 2. What are our possible zeros? How do I come up with possible zeros? The root 0 theorem, right? P over Q, right? Okay. Did you guys have those? Sure. How many zeros am I looking for? How do I know that? The degree. You guys are awesome. Good. What is the y-intercept? How do we know what the y-intercept is? It's the constant. Good. Is there a GCF? Can you take out an x from everybody, right? Okay. What about, can I factor? Right? I might be able to factor before I even start finding zeros, right? It's possible. Okay. Can I factor by grouping? How many terms do I need to factor by grouping? 4. Need 4 terms to factor by grouping. Right, Chris? You don't use the quadratic formula, but you could always use the quadratic formula. Why is the quadratic formula for Mrs. Muller my last go-to? Oh, wait. I want to hear it from Mama. Why? And as it's taking a long time to do, what's the possible outcome that can happen? You can make mistakes. There's a whole bunch of positives and negatives and squares and square roots. I mean, it's a lot of work, right? And a lot of room for error is the way I look at it. Yes, Mom? The grouping comes from the quadratic formula. It's not more accurate. No, it's not. It gives you the same answer. The quadratic formula can tell you multiple things. Yeah. It can tell you where the axis of symmetry is, right? We learned that. It does have its value. It's just not my go-to. Okay, let's keep going. Can I solve by square rooting? That's going to be a big one right now, right? Okay, what was the one I heard that somebody said that I don't have up here? I heard it. You don't want to share it? Missing, okay, what do we call that? Yeah, missing place values or poles. Poles. Okay, so I'm going to I should have put that on here. Holes. Holes. Got holes? Put that up there, right? Okay, so here's number 1 on the worksheet that I'm going to give you today. There's only 8 questions on the worksheet. It's going to go super quick. It's even easier than yesterday's homework. What's designed today is to get through it really quick and then go back to yesterday's worksheet and fix it, okay? All right, so this is already starting to be factored, correct? You should already start to see some zeros here. First of all, what's my degree? There are 5 x's up there, right? There's 2 here, x and an x. There's 2 here, an x and an x, and there's 1 here. So this is degree 5. What is the y-intercept? It's 0, 0. Because there's an x out in front, right? And that x has a minus 0 associated with it. So if you multiply all of those together, you're going to get 0. Okay, that's the tricky one. Okay, so I already know that I have one of my zeros, right? So 1, 2, 3, 4, 1, 2, 3, 4. One of my zeros is already at 0. And not only is it at 0, but it's a double root. Why don't I just what? I like that idea. That's a good idea. The only reason I don't like it is if I like have a 2, then that looks like 4. But we'll put parentheses around it. Yeah, I like it. Okay, so I have a 0, and it's a double root. How about that? Better? Okay. So 0 is my double root. I have another root here that I can get. All of this I can set equal to 0. 2x squared minus 50, 2x plus 1. So I'm going to take out that one. So all of these are set equal to 0. And 2x plus 1 equals 0. I can solve all of them that way. So if I move the 50 to the other side, I'm going to have 2x squared equals 50. Then if I divide both sides by 2, I have x squared equals 25. Then if I take the square root of both sides, x equals plus or minus 5. All right? Plus or minus 5, so I have a root at 0. I actually have 2 of them, right? It's a double root. I have a plus 5, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So there's 1, 2, 3, 4 of my roots. I only need one more. So that would be here. When I move this to the other side, I get 2 x's are equal to negative 1. When I divide by 2, I get x is equal to negative 1/2. So I have a negative 1/2 right. So here and here. So it's 5. What does it look like? It's an odd function, right? And so we're going to go, I have to start up here, right? My y-intercept is at 0, but it's a double root. So I know it skims it, and then it kind of has to come back up here. So there's number 1. Sure. Yes. You want it? welcome. Okay. Number 7. I'll go back. You have to be quicker. Okay, so what are some things I can ask myself? Are there any holes? 4, 3, 2, 1. None, right? Are there any holes? Is it positive or negative? What is the degree? What is the degree? 4. What is the y-intercept? 0. Okay, now what do we start asking ourselves? What are the possible zeros? 0, right? I can't get anything from that, right? P over Q, my P is 0. No. Anything times 0 is 0. Okay, so now what should we ask ourselves? Yeah, does it have a GCF? It does, but is it factorable by grouping? It might be. We could try different approaches on this one, correct? I'm going to see if it's factorable by grouping first. Okay, so if I take the factorable by grouping, so I should pull out x cubed from here, and I'm left with an x minus 2. If I get something x minus 2, then I know it's factorable by grouping, correct? So let's pull out a negative x, and I'm left with a positive x, because negative x times x is negative x squared. Should have done that in a different color. Negative x, and I'm left with an x, and then positive 2x. Since I pulled out a negative, it needs to be a negative 2, because negative x times negative 2 is positive 2x. And so yes, it is factorable by grouping. It's not a difference of squares yet, but we're getting there. So now I have an x cubed minus x, and then I have x minus 2. Right? If I factor out an x minus 2 from both of them, if I factor out the x minus 2 from both of them, remember what this looks like? Factor out an x minus 2 from both of them, I'm left with x cubed minus x. All right? That's that. Now I'm going to factor out an x. So factor out an x, and I'm left with x squared minus 1, x minus 2. What am I left with here? I can factor this down even further. Like Lama said, difference of 2 squares, x plus 1, x minus 1, x minus 2. And what I'm thinking, and which I was totally said wrong earlier, was that yes, there is a plus 0, but because of looking at all these zeros, it looks like the coefficient, that last coefficient 2, I could have done P over Q. Correct? Are we learning from my mistake? I have a coefficient of 2, so that would be plus or minus 1, plus or minus 2. It looks like it. I didn't know that, didn't realize that, but that's what it looks like. We'll have to check another one that doesn't have a constant at the end and see if it does the same thing. Yes. You could have done that as well. We could have. You could have factored out an x in the very beginning, and you still would have gotten here. You still could have factored by grouping by pulling out an x from everybody. Okay? Yes, Kane. Yes. It shouldn't matter, right? Because it's still that end term, right? That would make more sense. Yes, Essence. You don't need to. The only reason you should use synthetic is if nothing else works, right? Your first go-to is to use factor by grouping. The only reason to use you could use synthetic through the whole entire thing if you wanted to. You don't have to factor at all. But why do that? I take that back. You can't use synthetic if you have imaginary zeros. You're not going to find those roots unless you want to start guessing, right? Okay. All right, so I've just done 2 of the problems on your worksheet, and I'm going to give you some time to work right now, lots of time to work actually, and you guys can go ahead and start asking me questions, but I want to give it like about 10 minutes, okay, 10 minutes of working time, and then you guys can start asking me questions. Let's look at this. This was yesterday's. I put this on your, oh, this is not one I put on here. This one, yesterday, did I factor by grouping on number 2? Sorry, number 3? We did synthetic first, right? Could we factor by grouping on this one? It looks like it, right? So I could have gone straight to factor by grouping on this. I could have factored out a negative, right? I could have factored out a negative from this one. So negative, actually, thank you, negative x squared. And if I factor out a negative x squared, I have x plus 1. And then I have a 5 plus 5, x plus 1. Would have been a lot easier, right? So it's advantageous to try and use everything you can use until you can't. What? Can you think of a better one? There you go. Perfect. Okay. All right. So this is going to be, let's see. I factor out x plus 1, and I'm left with negative x squared plus 5. Now you set them both equal to 0. I already know this when it's equal to 0 is going to be x equals negative 1. So let's set this one equal to 0. So we're going to have x squared it won't be imaginary because I can divide both by negative, and then I get x squared equals 5, x equals plus or minus root 5. Those are my other 2 roots. So I have 3 roots, and that's right, I have 3 roots. Okay, this one I gave you guys a hint on the presentation last night. Right now it's the difference of 2 squares, but there's a square inside of it. So x squared and x squared. And 16 is 4 and 4. And positive and negative. But it's not done, right? You got to solve for that as well. You could just solve by square rooting, or you could see that's the difference of 2 squares. But this one you're going to have to solve by square rooting. So I'll give you that. I'm going to give you some time. I'm going to pass out this worksheet. I'm going to give you some time to work on both of them. You can do this worksheet at home tonight and just work on your homework. But let's say your homework from last night is due in, I'll give you 10 minutes to work, and then I'll give you 10 more minutes. So in 20 minutes, your homework from last night is due. Okay? Sound good? All right, go. No. Okay, so some stuff I can ask myself, right? Here are our steps, P over Q, list possible roots. So what are our possible roots? I have 4 possible roots, right? And of those possible roots, they would be plus or minus 1, plus or minus 2, plus or minus not 3, not 4, not 5, not 6, 6, because 6 times 3 is 18, and 9, and 18. There's 7 doesn't work. Plus or minus 3, I messed up. Thank you. Plus or minus 3, good job. There's a lot of different ones, right? Or I can factor this. There's a trinomial in there. It is a trinomial, correct? Right? It is. It's just got x squareds in it. So instead of being x and x, it's going to be x squared and x squared. Make sense? So 18, what two numbers make negative 18 when I multiply, but when I add, make negative 7? 9 and 2. And then 9 needs to be negative to make a negative 7, correct? So now I can set both of those equal to 0 and square root, correct? This one I don't need to square root because it's already the difference of two squares. So this is x minus 3, x plus 3, and x squared plus 2. So I want to factor x squared plus 2, so I bring it over here and I set it equal to 0. Sorry. X squared plus 2 equal to 0. X squared equals negative 2. So x equals plus or minus I root 2. I shouldn't skip that step. Take the square root of both sides. And I get x equals plus or minus the I under the square root, sorry, the negative under the square root makes an I, and then I have root 2. Better, Susanna? Uh-oh. I thought I had a graph underneath here. I do. So, 1, 2, 3, 1, 2, 3. This right here gives us a y-intercept of 0, negative 18. 0, negative 18. What else? We have a 0 at 3. We could say plus or minus 3. Plus or minus 3. And we also have a 0 at plus or minus I root 2, which is going to be imaginary, and it's not going to hit the x-axis. So here's one at 3. Here's one at negative 3. It's to the 4th degree, so it's going to look like a W, and it's positive, so it's going to be pointing up. Could look anything like that. All right, I think that's it for my recording.